Hey guys, so today with our last set of notes of chapter 4, we are going to put everything we have learned in this chapter together, everything about histograms, box plots, describing distributions, identifying outliers, into this final example, which is about comparing distributions. So, reminder, when asked to describe distributions, we should be giving exact values for both measures of center and both measures of spread. So, also, work for outliers must be shown. So, make sure just in general that you are giving the value of the median and telling me it's the median. So, the value of the center and then telling me that that's the what statistic you're using, and along with the measures of spread, telling me what statistic you're using, giving me that exact measure. So, this first example is a little recap of what we've done thus far in this chapter. In 2001, NFL season, Tom Brady of the New England Patriots took over the quarterback position and led his team to a Super Bowl championship. Here are his passer ratings from each of his 15 regular season games. So he must have missed a game this season for some reason, but 15 games, there you go. So go ahead, take a minute, and put this data into your calculator. Remember, in order to get to a list, you go to Stat, arrow over to Stat, and then hit Enter, and then enter your data into the list. Okay, in order to clear out those numbers, you arrow to the top so the list number is highlighted, hit clear, and arrow down. Okay, so go ahead and enter those values. Take your time to make sure you enter them into your calculator correctly. Now, go ahead and pull up your one variable statistics by going to Stat, arrow over to Calc, and number 1. Remember, if your data is in list 1, you can just hit Enter. Some of you might have a different menu come up. Just make sure it says list 1, and then I think you have to hit Enter 3 times, and your one variable stat should come up. Now, go ahead and scroll down, because it says it wants us to make a box plot. So go ahead and scroll down to your 5-number summary. Okay, and let's just write those values to help us make our box plot. So hopefully you got a minimum of 57.1, a quartile 1 of 62.1, a median of 78.9, quartile 3 of 93.4, and a max of 148.3. Okay, so let's go ahead and make the box plot. Make sure you draw a number line first. So my minimum is 57, my maximum is 148.3. So I'm just going to go by 20, starting at 40 and going up to 160. Now, before I can make my box plot, I need to check to see if there are any outliers, okay? Because outliers, we learned in the previous day's notes, need to be marked separately in our box plot. So let's check to see if there's any outliers. So I'll just do my word to outliers down here. So remember, we're checking in two directions. We're checking the lower direction which outliers would have to be less than Q1 minus 1.5 times IQR. And we're checking in the upper direction, in which outliers would need to be greater than Q3 plus 1.5 times IQR. Okay, so plug in the value of your statistics from your 5-number summary. Q1 was 62.1 minus 1.5 times IQR. Well, let's see here. My IQR, remember, is Q3, which is 93.4, minus Q1, which is 62.1, for a difference of 31.3. So my IQR is 31.3. So if I type that into my calculator exactly how I see it, you get 15.15. So outliers in the lower direction would need to be less than 15.15. Well, my minimum is 57.1. So do I have any outliers in the lower direction? Nope. So none in the lower direction. Now let's check the upper direction. They would need to be greater than, from above it says my Q3 is 93.4, plus 1.5 times my IQR is 31.3. I type that into my calculator exactly how I see it. And I get 140.35. So outliers in the upper direction would need to be greater than 140.35. Okay, so my maximum is 148. So we know there's at least one outlier, at least the maximum. So let's check the data set. So yes, and it looks like 148.3 and 143.9. Okay, those would be your outliers. So those need to be marked separately when we're creating our box plot. So let's go ahead and make our box plot. I'm going to put, there's no outliers in lower direction, so I can mark my minimum, which is 57.1, quartile 1, 62.1, median 78.9, quartile 3, 93.4. Now, I am going to make my lower whisker in my box. So I'm going to connect the minimum to quartile 1 to make my lower whisker. Then I'm going to use my quartiles to make the box. And draw a line through the median. Now, my outliers need to be marked separately. So I'm going to mark 143.9 and 148.3 separately. Now, my upper whisker is going to go to my highest non-outlier value. So I'm going to look at my data set. Well, that's an outlier. It looks like that's an outlier. 124.4 is my highest non-outlier value. So I'm going to connect Q3 to that to make my upper whisker. And there we go. There's my box plot. Now, the last thing we need to make sure we have in every graph is a title. You can include your unit in your title if you want. You can put the title up here or down here in a box plot. This was 2001. The date is definitely important. We have the athlete, Tom Brady, and these are his passer ratings. Okay, so Tom Brady's 2001 passer ratings. Okay, last thing it says we need to do is describe the distribution. And that's, remember, is think of the word SOCS, S-O-C-S. So I'm just going to do that right down here. I'm going to kind of weave the first two parts of SOCS into one sentence. So the first, well, it doesn't matter which S is which, but typically we talk about the shape first. Now, remember, shape of a box plot can be tricky, and we only typically use like skewed left, skewed right, and approximately symmetric. So, skewed left, if a box plot was skewed left, that would mean the left side of the box plot from the median to the minimum is more stretched out than the right side of the box plot, median to the max. Now, typically we don't talk about outliers because they can affect a lot of things, definitely including the shape. So, we can just look at the box plot without the outliers right here. If the two sides of the box plots from the minimum to the median and the median to the maximum or the highest non-outlier value are approximately the same distance, they'd be approximately symmetric. However, in this case, it looks like the right side of the box plot is more stretched out. Therefore, this box plot would be described as skewed right. Okay, and as we checked earlier, there were two outliers in the upper direction. So, this distribution is skewed right with two outliers at 143.9 and 148.3. Okay, now the remaining part of SOCS, center and spread. Now, as long as you, I am okay with you just talking about one measure of center, one statistic for the measure of center, and one statistic for the measure of spread. So just tell me what you're using though to describe the center and describe the spread. So for the center, you can use the mean or the median, but tell me which one you're using because they're probably going to be different values. For the spread, right now, we know two different measures of spread, range and interquartile range. Tell me which one you're using. And in fact, next chapter, we're going to learn a third measure of spread. So, see, I already have my median written up here, so I'll use 78.9 for my median, and I've already calculated my IQR, 31.3. So, the center can be described using the median of 78.9 and the spread using the IQR of 31.3. Okay? So that's a pretty big problem on your test. That would be worth lots of points here, okay? At least a 10-point problem in all with all of this information. So keep that in mind. I realize it's long, but it would be worth a lot of points. So that's kind of a review of the first 3 sections from this chapter. So let's move on to what's new today. When asked to compare distributions, discuss the similarities or differences in the values for the center and spread instead of giving exact values and just regurgitating information. So, for example, remember, we're comparing, so make a comparison statement. First hour had a higher measure of spread compared to second hour, okay? I don't need to know that first hour's average was this, second hour's average was that, and then I have to figure out the comparison in my head. Give me the comparison statement. So, for example, which would be better when asked to compare distributions? Distribution A has a higher median than distribution B, or distribution A has a median of 5.7 and distribution B has a median of 2.3. Now, I realize that part B gives a little bit more specific information, but when you're just asked to compare, I'm just trying to make a comparison statement between the two. Okay, so when comparing two distributions, I'm going with letter A on this one. Make a comparison statement. Again, which would be better when asked to compare distributions? Distribution A is more consistent than distribution B since the range and IQR are smaller. Or distribution A has a range of 17, IQR of 5, and distribution B has a range of 45 and IQR of 27. That's a lot to wrap my mind around it. Like, wait a minute. Okay, now I have to compare, wait, what was their range again? And what was their IQR? And wait, what was the first one? Make the comparison statement for your reader. Again, statement A here is better when asked to compare. Okay? So let's take a look at the next example. It says, here are box plots for the number of runs scored for the American League and the National League during the 2008 season. Notice the plots are in the same scale, okay? So it looks like it's runs. So otherwise, yes, it'd be difficult to make connections, surely, if this was like if they were drawn on different scales. So let's compare these distributions. So before making your comparison statements, I kind of like to jot down some quick notes about these distributions. Okay, so again, we're comparing the distribution, so we're going to reference socks. So shape. Well, let's look at the shape of these. Okay, National League definitely appears from here to here, appears to be about the same distance. Remember, it doesn't have to be perfect, it's approximately. And same with the upper half. So I would say National League is approximately symmetric. Also here, this has a longer lower half of the box, this upper whisker. You could say American League is also approximately symmetric, but if you feel like they're a little bit more skewed left, you could say that too. But I would take either one for both of those. You could say slightly skewed left, but if you said approximately symmetric, that's fine too. So for the shape, I'm going to go with American League is, we'll say, I'm actually going to go with they're both approximately symmetric. But like I said, if you feel like the American League is a little bit more slightly skewed left, go for it and say that too. But they're fairly close. Okay, outliers. Now these are box plots. We know in box plots that outliers are marked separately, so we can clearly see that there's no separate points on either of these box plots, so there's no outliers in either distribution. Center. Well, center is drawn in for you on a box plot. It's the median. So here's the center for the AL, and here's the center for the National League. Those are their medians. Well, just by looking at it, the lines, which league has a higher median? Well, the American League, because it's pushed farther up on the number line. So the American League has the higher median. Now let's look at the spread. You can look at the range, which is the length from max minus min, or you can look at the IQR. The IQR might be a little bit easier to compare here. IQR is Q3 minus Q1, so it's essentially the length of the box. Which one has a longer box in these two plots? Well, it's your American League. You can see the length of this box is definitely longer than the length of this one. So the American League has a higher IQR. Again, you could have also talked about range here, which it looks like the American League has a higher range. That's fine too. But for center, I don't know how you could talk about. Mean might be a little bit difficult to talk about, considering the fact that you don't have all the data. Okay? So let's go ahead and weave this information into two sentences to describe these distributions. So, both distributions are approximately symmetric and do not have any outliers. Now let's weave the last two together in one sentence. The American League has a higher median as well as a higher IQR compared to the National League. And you can use AL to abbreviate American League and NL to abbreviate National League. Okay? So that's an example of how you could compare two box plots and their distributions. Now, another way to graph numerical variables that we talked about this chapter was with histograms. So here are the results of an experiment that compared kicking distances with warm footballs, that's the histogram below, with kicking distances of cold footballs, which is your distribution above. Compare these distributions. Okay, so again, I am going to just kind of slightly jot down some information and then kind of put it together. You don't have to do this part, but I do find it a little bit helpful. So, the shape of cold footballs. Well, the shape for cold definitely looks about the same for each one. I know this one's a little bit lower, but if you look at the scale, they're mostly right around 2, some at 1, and a couple at 3. So the shape for the cold, I would definitely probably say is uniform, or you could use the word approximately uniform. Now for warm footballs, if you go like this, I definitely see somewhat of an approximately symmetric shape. Or, I know some people see these two peaks here. You could reference that as bimodal. Either one would work. Okay, so either approximately symmetric, or you could say bimodal. Just pick one and go with it. Oh, outliers. Now, outliers aren't marked separately like with a dot or anything like in box plots. So for histograms with outliers, you're looking for gaps in your data set. Okay, do you see any gaps between the bars in your data set here? I don't see any, so I'm thinking there's no outliers here. Now, measure of center. Who would have the higher measure of center? Well, notice the data for warm footballs is shifted up higher on the number line than the data for cold footballs. So I'm thinking warm has the higher median. Now, what about for spread? Spread, you could use the range or IQR. I think the range is going to be a little bit easier here because you can identify your max and min rather than trying to identify your Q3 and your Q1 to find your IQR. So my range for this one, for cold, if I follow this down, that's 60. If I follow my minimum down, that's 52. So 60 minus 52 gives me a range of 8. My range for warm footballs would be, this one right here is in the middle, so that's 63 minus 55, and that's also 8, so the same range. Okay, so now let's put this together to compare these two distributions in complete sentences. So I'm going to say my first sentence, I'm going to talk about shape, okay? And since they have different shapes, I probably can only just use one sentence, and it's got to all be gopher shape. The cold footballs, the graph for cold footballs is approximately uniform, while the graph for warm footballs appears to be, I'm going to go with bimodal. But like I said, if you saw approximately symmetric, that's fine too. Your next statement, maybe talk about outliers. Since there are no gaps in the graphs, there appear to be no outliers in either data set. You don't have to talk about the gaps, but maybe for the sake of notes, it's good too. So since there are not any gaps in the graphs, there appear to be no outliers in either distribution. And for the last sentence, I bet you can put center and spread together. The distribution for warm footballs appears to have a higher median. However, both distributions appear to have the same range. The distribution for warm footballs appears to have a higher median. However, both distributions have the same range. Okay, so that's putting together pretty much everything we've learned from Chapter 4. You'll be reviewing and taking your test in the next couple of days. Feel free to let me know if you guys have any questions. Good luck, guys.